super nice to be here. Yeah, isn't it? In person.
Finally, yeah.
Yeah,
it's really people.
Okay, so, anyways, I'm super excited about the manager and how that works, and hopefully teach you maybe a thing or two about the window manager, and maybe bring some new insights and a deeper appreciation for what Android does and how it works. So, this is Vadim.
Hello.
I'm Pablo. Hello, everyone. And we're part of the Android framework team, specifically the Android team, and we're from Zero. So, window manager. Our goal today is to give you an overview of what the window manager is, its key responsibilities, and tell you a bit about how you can control it. As you know, engineers, not necessarily the best at naming things. That's one of the hardest challenges we have. And although the window manager does control windows, hopefully, thank God it does that, otherwise that would be super confusing. But it also does a bunch of other things. Activity life cycles, inset, animations, managing displays, and a whole bunch of other stuff. Our main view for the presentation today is going to be to describe first, starting off with how windows work.
Yeah, I guess to understand what the window manager does, we need to understand what a window is, and obviously we won't be talking about this kind of window that we have in this room. We're going to talk about window in the context of operating system. So we have an example of the first window that came to life on the macOS Apple II, I think. And if it was not obvious enough, some manufacturer called their operating system Windows. So we have window. In the context of desktop operating system, it's pretty obvious what a window is. It has a title bar, it has a border, so it's really easy to make sense of it. But when you look at a mobile operating system, whether it's Android or iPhone, it's kind of hard to see how many windows we have in this screen. Here, who thinks there is only one window here? I think there is two. 2, 3? More? Okay. Yeah, so the right answer is 3. And let's just take a... So we move to the recent view because I think it's a little easier to see what's happening here. So obviously we have our main content, which is our app window. But we have two more windows that we could see before. The first one is the status bar, which is controlled by System UI, and the same for the navigation bar, also controlled by System UI. Both windows have a transparent background, so we can actually see the window beneath, which is quite important later on. So let's get back to our app window, and I would like to introduce another concept, very important, activity lifecycle. Anybody heard about activity lifecycle? Good, okay. If you haven't heard about it, I think you're in the wrong conference, so you can take some time and leave now. All right, so activity lifecycle, for the one who actually know what it is, you know when to use it, you know what to do in onCreate, you know what to do in onResume. I'm not teaching you anything new here. But have you ever wondered who is actually pulling the string of the activity lifecycle and who is calling the callback, who is starting the actual activity, who is creating the instance of the activity class? Well, I guess by now you might have guessed that is the system, and more specifically, it's the window manager. Oh, I missed one slide. Who's pulling the string? Okay. Your turn.
So, the window manager is responsible for orchestrating the whole process around starting the activity, running it, getting it on screen, stopping it, getting it off screen. But really fundamentally, the reason why it does all this is because the window manager is there to allow apps to safely share the display. So it's there to get the app on and off screen and decide how and where to show it. And if you take a step back, we have these kind of systems for sharing the CPU, the memory, and obviously the display being a shared resource, we need a similar system to share the display. And to do that, we need two things, or at least two key things. The first thing, obviously, provide a way for applications to get stuff on screen, give them a window or some sort of surface so that they can draw on screen. But secondly, and importantly also, ways to enforce rules and a robust mechanism so that applications can't just draw wherever they want and do whatever they want to display. Otherwise, it would just hijack your whole system. So let's start with the first part. How do we get an application or an activity screen, and how does the window manager orchestrate the entire process to get from opening the application to it being on screen. So to do that, we'll go over this example here, where we're starting in the launcher, opening Chrome, to read this nice little article from the New York Times about how a window can possibly forever change our view of the Earth. I find that a little hard to believe, but so what we'll do is try to explain that little magic step right in between. So the first thing that has to happen, of course, is an activity has to be started. So someone has to request that to happen. And in our example case, the way that works, launcher sends an intent. Everyone's very familiar with this, with the category launcher, action main, package Chrome. And that somehow makes its way to the window manager. And along with the package manager, it decides, okay, I need to start the Chrome activity. And the first thing that happens once the request to start the activity get to the window manager is that it needs to create a task. So as you can see here, on the right-hand side, we have this little blue box, which will show the state of the window manager as we go along, and the representation of the application inside the window manager. So just quick recap, what exactly is a task? So a good way to think about it is basically everything you see on the overview screen, that's its own task. But really fundamentally, a task is just a collection of activities and organized in a way such that you have a stack of like the history, so the back email, open new email, pop an activity on top, go back, pop it off, open it to this one. You're probably all familiar with this. Obviously, we need one of those for launching activity. So we have a task. The window manager creates a new activity record, adds it on as a child in the task. But the important thing to remember here is that these two things are just containers. They don't actually directly show up on the screen. They're just there to store the state of the task, the activity, and maintain that state and enforce rules based on that state to figure out how and where to show the application. So, one more thing to remember about this is that we have a tree-like structure in the window manager. So that means that the states of the parents are kind of to the children. So if we hide a task, the things under it are hidden. If we move the task, everything else under it moves. So that's something to keep in mind. Now, what we're still missing here is something to actually run the application. Right there you can see that thing's running. So we need to actually create a process. Is responsible for something that requires to actually start the application to start the process to run the application. So how does that happen? In Android, we have the Zygo process, which you might be familiar with. It's just a process that contains all the stuff, like all the packages and code and memory required to run an application so that it can do that fast. So if you look at the definition of Zygo on Wikipedia, it's something along the lines as the initial cell from which an organism creates itself. So that's pretty much what it's intended to be. So the Zygo is just there, waiting for someone to request it to maybe clone itself and get an application process started from there. So what happens is the window manager is like, hey, I need a new process for my application. The Zygo's like, oh, I can do that. It's listening on that, and it just works itself. We get a new application process, which is a clone identical to the Zygo process, not doing anything, just sitting there idle and waiting for further instructions. Okay, so now we have this application, which is the clone Zygo process doing nothing. We now actually need to start this activity. So we request to start an activity thread, and when that boots up, it starts a whole bunch of initialization. And importantly, it registers itself back with the window manager and sets up all the lifecycle callback connections that it needs so that we can actually now start running the lifecycles, starting with onCreate.
Cool. So we have our application that is created. Oh, I forgot to remove this one. That is good to do. And I didn't know to ask it. Like, I can just improvise on this one. Like, When you call get root view, what do you think you get as a view in your application? Do you get like the content view, or do you get like some other view? Somebody has an idea? No idea? Okay, cool. So the next part will be quite relevant. So we are calling, we have our on-crate that is called by the system, and the first thing we're going to start to do is to set a content view on our application. So we have our main activity, we all know that. Actually, when you call set content view, it's the first time you truly interact with the window manager. So what's happening here is that still in your application process, you have the fun window that is created. And the fun window will be the representation of a window. It won't be the actual window. It will be the representation of your window within your app process. Historically, the fun window holds also the title, so you could set the window title, which is that in a bit. You could set the action bar and the menu that have now been replaced by toolbars. So we have our fun window, and our activity actually requests now to the window manager to create the actual window that will contain our data. But in reality, the call is a cross-process call, so it's not a direct call to the window manager. The window manager lives in the system process, so we need to find a mechanism to call from the client to the process, and this is done through the binder. So let's do a little kind of parenthesis on to what the binder is. I won't go into much detail because honestly I don't know the detail. The people, or should I say the person who invented that is way more smarter than me. I think Diane, we were there at the beginning of Android, wrote that. I think it's also part of the kernel, of the Linux kernel now. There has been discussion on whether it should be added to the kernel or not. So if you see the thread, if you Google binder, you'll see a whole thread on discussion whether to add the kernel as a to add the binder as a cross-process mechanism in Linux. But they use something else. We use the binder on Android. So on one side we have our app process. On the other side we have our system process. On our app process we have our service that wants to be called, but this service is just a stub implementation. There is no actual code running there. What's going to happen here is we're going to use the binder and the binder proxy, which is going to serialize our data. So for instance, we have like an image and some bar object to put on the other side of the process. So the binder serializes that, pass it through the kernel to the other process. The other process makes a copy, the kernel makes a copy, and then deserialize it using the binder stub that will call the actual service implementation. So the window will be created in the implementation on the system process. So we make the call. That's the actual method that is called add to display as user. It's a private method, and this method passes an iWindow object, which is which will be used as a token in the server to identify our window. So at this point, we have a clear representation in the system server of our application window, and we can use this token to find it in a map to whenever we need to do any interaction with the window. Right, back to our activity. Our fun window is created. We call install decor. So that's gonna create the decor view, which will be the actual the top view of the hierarchy. I shouldn't say the root view because it's not the one that is returned, but it will be there won't be any other view about that. And the responsibility of the decor view is to take over what the fun window was doing before. So fun window was doing title and everything. Decor view now takes care of styling the status bar and the navigation bar. Like we can see here, we have like the background of the status bar and navigation bar. And on system UI, we only have the foreground of the status bar and navigation bar. So let's take a little step back in history. And on the right side, you can see Gingerbread, which was the version of my first Android device, Narcos, French Narcos. I really love this device. I thought it was better than an iPad at the time. It wasn't, but it was great anyway. It was cheaper, so it was better, probably. Yeah, and on the left side, we have like a modern app, so Twitter, using like a status bar styling. You see of the app that sits below the status bar, so that hasn't changed much. But you can see that the status bar on the Twitter part is now colored, and that's colored by the decor view. So, yeah, Windows, the window title I mentioned before, that is obsolete. So it still exists in the code here, but nobody uses it anymore, hopefully. And yeah, on the other side, we have like the decor view. And I think like what's interesting here, it made me realize what the flag, for instance, window draw system bar background, which for me was kind of cryptic the first time I used it. No, it makes sense because it means that the window of our application is responsible to draw the background of the system bar. So you have a bunch of flags that are like window, which means that your decor view is actually doing stuff on your application. Could also be, if you have a full screen activity, it could also do the insetting of the content of your view. So to be sure you don't have any overlapping between status bar and your content. All right, so we have a fun window, we have a decor view, we still have our layout. They are not tied together, so now it's time to tie them together. We attach our decor view to our phone window, and the decor view has a special view, which is a content parent that will be the parent of our content. When you set content view, you actually add a view to m content parent. And there we go. We have our whole hierarchy all sitting on the app process, but nothing is still displayed on the devices. So how do we go from our hierarchy on the window manager to having something on device? We can divide in three parts. So we have application window manager and the actual hardware with the GPU and the screen. In the middle sits the window manager. So I kind of wanted to summarize this in like the application decides what to draw on screen, the window manager decides where to draw it on screen, and then the hardware and something in between makes it whole. So this thing is a surface flinger. Pablo will talk about it. And right in between, similar to surface flinger that sits in the middle of window manager and hardware, we have the viewer imp, which sits between the application and the window manager and kind of hold a reference to the window that is in the server and a reference to the view, the decor view, and it will pass along the canvas that you pass to your activity to actually draw. But please, give us the details.
So, we know about the windows and how that's laid out in the window manager, at least for application. We know how the view hierarchy looks like in the application itself. So what's missing is that little plug that links them both together to actually make the final thing and get it on screen. So we'll look into a bit of details of how that actually works and look at how surface flinger. So yes, not surface flinger, this is not a mistake. This is the window manager hierarchy. And we want to remember this because the surface flinger in a way is similar to window manager in that it also has a hierarchy of things. Layers instead of windows. So while layers will be very closely related to containing only the instructions of like how to draw things onto screen, so the opacity, position, and transforms. The windows will contain a lot more information on the state to be able to figure out different rules and how to enforce different rules and policies that will be passed along to surface flinger as just the lower level information that's required to actually encode all that into a buffer to draw on screen. So much like in the window manager, the surface flinger, that hierarchy structure also means that rules or data in the parent is trickled down to its children. So if the top thing is hidden, everything below it is hidden. If it's moved, all the other stuff below is moved and so forth, like you would expect. The role of surface flinger is then to take that hierarchy and structure of all layers it has and kind of collapse them into a buffer. So compose all of that into a buffer, which is just pixels in memory containing all the information that we want to display finally on the display. And that's then the what we call the frame buffer. And the hardware, the display itself, is set up to read directly from that frame buffer. It's configured to do that, the hardware itself. What we want then is to get that decor view from the application, or its final content, into that buffer layer so that it can be, with the rest of the hierarchy, containing everything else in the system, collapsed down into that final buffer that we want to push on screen. So So, this is just to quickly bring it up to something that you'd be familiar with. Really, the most direct thing that's a layer into the application is the surface view, which kind of more or less directly controls the layer. So you can think of all these layers as a surface view in the application. Now we have windows, and they're associated with a layer. But how does that window actually control the layer and send the information that it needs for surface flinger to figure out what and how it needs to draw stuff? So that's where the surface control comes in. That's the object that can move across processes and is used to control the layers. So when a window is created, it will create a layer, and the layer, surface flinger, will give it a surface control to control it. So now all our windows in our activity, or in our app rather, have a surface control. But how do we actually use that to control these layers? That's with transactions. So transactions are just a batch of instructions that are all processed at the same time. So we have all these different instructions like simplicity, set position, and importantly in our case we want to focus on set buffer, which when given a surface control and a buffer, so just some graphic buffer in memory, it will apply all of that into these layers here to later be composed and shown on the display. But if you remember, what we want to put on the display is actually the application process, not in the window manager. So we need to somehow move that line of control into the application so the application can control its layer for its activity. How that happens is described as this diagram here. But remember how we have the which kind of tries to bridge the gap between the window manager and the application. So when the activity is ready to draw, so after on resume for example, it will perform a traversal. So what that means is just go over the view hierarchy and really get it ready to be drawn on screen, and then drawn into a buffer on the application side. The first thing that needs to happen is read out windows call. So that will be called the first time it runs, but also anytime there's a layout change, so orientation change or that kind of stuff. It will request a surface control for that window inside the window manager. So then the window manager sends back the surface control for the application's window that controls the layer to the application. So now in the application we have a surface control, so we have a line of control from the application to surface flinger to control its window. To control the layer and the buffer when you show on screen. And the final thing that happens, that needs to happen is we actually need to perform the draw on the application. So perform draw gets run, and it creates that buffer, basically composing all the views in the application. And if you want to learn more about that, Ramon over there did a nice little talk on that a few years back. So I guess you can try to travel back in time maybe 3-4 years, or YouTube maybe easier. So back to this. We have our buffer, we have our surface control in the application. So we want to update that layer. As I said before, transactions are able to do that. So we send transaction over to update that. And the way that looks is just set buffer with a surface control and the buffer for the application, and the application and sent over to service flinger. So to recap, how do we get back from the application? With the buffer, taking the buffer from freezes all that, puts it into the frame buffer, and finally prototypes every time you display request will read from that frame buffer, and we have what we want on the screen. So we've now seen how applications, or how the window manager provides a way for applications to draw on screen, and how it orchestrates all that process to get apps and windows onto the screen. But we've kind of touched briefly upon how rules are enforced and maintained so the application can draw anywhere it wants, but let's dive back into that. So back to our for our application. So we have the task on top, the activity record, and finally the actual window for our activity. Now, remember how this hierarchy for stuff defined in the parents to be pushed down to the children. That means that as long as the window manager has control of the spot layers, it can indirectly control all the children layers. So although the bottom window activity and its corresponding layer through source control is given to the application and it has control over that, because the window manager still controls everything else above it, it can do whatever it wants, and it can still enforce things like hide this whole activity, hide this whole task if you go back and forth between activities or close the task or whatever else might happen. And now, if you look at the window manager, is much bigger than what we've talked about. So this would be what is visible on screen is actually more going on mode. So we have down here in the bottom, and this whole extra big structure on top with a bunch of other windows. Most of these are just containers which contain information in the state, and are there to help control the position of things on screen. So the bottom ones, the ones in orange, are the ones which actually contain the actual windows that contain the information that we show on screen. So to kind of illustrate how all these things above help us control and enforce certain features and ways to display information on screen. These are a few examples. So, for example, here, if you look at the one-handed mode, going back to the slide, we have display areas with one-handed mode, so windows which contain other sub-windows in there. And what we can do then is just apply instruction of the state of those windows, which will then propagate the information to surface flinger. And in the same way as the window manager is propagated down to the flinger as well. And we can just say, oh, move that whole thing down, everything in it moves down, the application moves down, and it can draw out of those bounds.
Right. So we gave a pretty good overview of what was going on behind. We're on time. So all of this process takes a lot of time. When I say a lot, it takes around 300 milliseconds on like a Pixel 6 Pro, and probably around 1 second, even more on like low-end devices. So we call that the app startup time. You can't really fight against it. It's a system doing stuff, but you still have some power over it, which is the little bit at the end, the dark blue, where your application might actually be doing things like querying a local database or potentially doing network call, but you shouldn't really not do that kind of things during your app startup time. So how do we deal with either seeing delays or potentially flickers when you have a layout shown and the data is not ready, so the layout starts to pop up while the data is coming in? We use the splash screen. So splash screen is a window manager feature that was introduced in the last release, so on with 12. And the splash screen just sits in between this app startup time, so it doesn't delay your application. It's really filling this gap, so the user sees something happening as soon as they click on the launcher icon. The splash screen is a special kind of window because it's running, so it's a starting window. It has its own rule and can do more things than a typical window. but it's created in the system UI process. So I talked about the system UI process before, drawing the status bar, navigation bar. This process is always running. So we always have a process to bring up the window right away, and there is no delay. So that we leverage this process to display the splash screen. Yeah, so that's an example of splash screen. So how do you control the splash screen? You can customize it. You can customize it by changing the icon, changing the background of the icon, the background of the window. By default, it will use the launcher icon. And yeah, you can. So yeah, the icon can be animated using an animated vector drawable. We don't support Lottie because it's very complicated. Chet, maybe one day we'll support Lottie. I don't know. Looking at you, hoping. No, I think it's a no. So we're still going with AVD because of Chet, but that's fine. I bought a second book to say sorry about this joke. And yeah, so splash screen is a 112 feature, but we have a library still in beta, but you can use it and backport the splash screen behavior down to API. It's good down to API 21, but if you really want the same behavior, you start at 23 because 21 and 23, that's like a weird scaling of the vector that we couldn't go around. And in your manifest, you will set your theme as the starting theme being the splash screen. So either you set it for the whole application or you set it for your activity. In your theme file, you will have your theme app, your app theme up there, and you add to this one, the one we just defined it in the manifest, theme that add the starting, that as for parent, theme.splash screen from the library we just added before, and you set all the attributes that we mentioned before to customize your splash screen. Then you just call install splash screen, and if somebody has a better name than install splash screen, I'm happy to take it, because it does not really install the splash screen on your activity. At this point, the splash screen is already shown and your activity is created, but it installs the instance of the splash screen object on in your activity, so you can actually do some stuff with it. So, as I said before, your application is doing some stuff in your onCreate, between onCreate and onResume, and you probably want to keep the splash screen up while you're doing this loading. Otherwise, you might just show an empty layout. So it's better to keep the user waiting on the nice AVD animation that you provided. So to do that, one easy thing to do is in your view model, you set a property is loading that you pass into the set keep on screen condition from the splash screen object. And this value is evaluated almost every frame. And whenever this value is false, the splash screen is removed and it will be shown. So in your view model, you load your stuff, and when it's done, you set the value to false, the splash screen is removed, and we're all up ready to go. What you shouldn't do. Vadim does it. A lot of apps do it. So they have like a loading, kind of a routing activity. Hopefully, by now, you should not do it, and you should have switched to compose or navigation component, where you have a single activity and the splash screen is handled by your single activity. I know this is not the case in real life. You might have a login activity, you might have authentication activity. So the way you could, before migrating to a single activity pattern, the way you could do that is to set the keep on screen condition to true, and you don't change that. And whenever you start your next activity, you will handle every splash screen related stuff in your next activity. Yeah, and finally, you can also customize the exit animation. So if you really want to take the whole experience, you have here we have an AVD of our diagram, which is followed up by a Lottie animation. It's not so. I mentioned Lottie animation. It's not running in the system here. Lottie animation is in your app. So like here you have full control. And then after the Lottie animation is finished, we do a circular reveal. So we actually hide our fake splash screen. I say fake splash screen because when we do that, we copy the splash screen into your app process. So we don't. There is a seamless transition between the system splash screen and the one that is copied in your app process, and then you have full control over it. It's just a in simple view that you can access with the splash screen view provider that provides access to the splash screen and to the icon view and to the animation, so you can synchronize the icon animation with the exit animation. How do you actually use that? So again, we have instance splash screen, and you set the non-exit animation listener on your splash screen, And here we simply apply some Lottie animation onto our icon view. So, okay. So we change our icon view. So we basically, what's happening here, we hide the splash screen icon and we replace it with the Lottie animation. The code is on GitHub. If you look up on my GitHub, you'll find it. Then you do the circular reveal at the end of the Lottie animation, and finally you fully hide and remove the splash screen animation using the view provider.remove. And there you go, that's your full end-to-end animation. So just to recap what's going on here, the app starts. While the app starts, the splash screen is shown. You might do some transition between the splash screen of the system and the splash screen of your application. Then you might do some in-app transition if you do some like shared element transition between the splash screen and your application. And finally, your app is ready to draw. And again, if you just use default splash screen, it doesn't add any loading time to your app. It just make your app more responsive to the first touch. And we're done here. Any question? Yes. Yeah. The first question was whether the structure we saw of the window manager always been the same. It wasn't. It was not a hierarchy before. It was just a set of window, and we had to manually calculate the bounds of the child windows so they don't overlap, they don't go outside their parents. It's been changed, I think, 3 years ago into a hierarchy, which makes it way easier to manage everything, including dealing with like multiple display, foldables. Yeah, so it changed. It's still changing, like the thing like display area. Pablo showed at the end where you can actually control the one-handed mode. It's very recent. There's a lot. There are a lot of things going on the window manager to support all kind of devices. Also like Chrome OS devices, tablets with Android 12 L for last screen that was out. So yeah, that's it's changing every time. So second question was about splash screen and whether it was available on previous version. So yes and no. We don't. We have some API, but not a simple one. Like if you get a window background on on an application, it will be set right before your app starts. So it's fine. It works. And that's actually what the library is doing. It uses the window background trick to create a splash screen before your app is actually running. So it's read by system UI, and the window is created before your app starts. We can display the window with a fake background. So we create a fake view using grabables in the library. So we cannot have any animated icon there, but we can at least show a still icon. So if you use the library, you have like almost the same experience, except the animation that is only available on Android 12 and onward. So that answers the last question with how to do it. So use the library, and that works. Any other question? Yes. Oh, I don't know. Yes, it is. I have no idea. Something. Yeah. Yeah, basically, like Pablo was saying that so he did a parallel to the surface view. Where is it? Did I skip it? Going forward. No, it was before. Backward. Yeah, but here. Anyway, so surface view when you have a surface view, you have control over the surface. It's using the same API that we are using this in the window manager. So yeah, you are actually pushing the buffer directly. I don't know, I mean, it's not hardware accelerated, but it's the closest you are to do whatever the window manager is doing. And? Okay, thank you very much.